Number 89 from section 6.1, we're asked to determine the domain and range of this function, highlight in blue, and use that information to state the domain and range of the inverse function. Then sketch the line y equals x, and we'll do that in red. So I'm going to say y equals x in red, and estimate the location of two or more points on the graph and use these to graph f of inverse. So we're not actually going to find the inverse, but we're going to use the information about this function to graph the inverse and find the domain and range. So let's start first by finding the domain and range of this blue function. The domain is all the x values, and we can see the x's start here at 0. And they go, they'll go on for infinity. So I can say x greater than or equal to 0 because it's a filled in hole, so it is equal to. And the range I'll do in a different shade of blue, which will be all the y values, and they start here at that same point and go up, and they'll go up forever along with that line. So that'll be y greater than or equal to -2. So there's my domain and range of the original function. The next task is to sketch in that y. Oh wait, no, it's not. The next task is to use this information to write the domain and range for the inverse function. So I did that in blue, so I'll do purple for domain and range of the inverse function. Okay, so the domain and range switch positions, but with also the x and y switch. So our domain is now going to be x greater than or equal to -2. I got that from the range. And the range of the inverse is the domain of the original function with the x and y switched. So that becomes y is greater than or equal to 0. So I use that domain function information to find the domain and range information for the inverse. Now, the next step is to draw that y equals x line. So I'll do that in red, or right through the corners of those grid squares, since I can see my scale is each one of these grid squares is 1 unit. So there's my y equals x line. Those two are kind of bothering me, the curvy. Okay, there we go. This is my y equals x. And let's do, to find the f inverse, I'm going to flip over that y equals x line. So if my f of f function had the point 2, 0, that means my inverse function will have the point 0, 2. And let's find another point that is convenient. How about that starting point of 0, 2? So that means on my inverse, I'll have 2, 0. Oh, whoops, I know, I see why this is wrong. This should be a negative, I'm sorry. So that should be a -2. So my purple will be -2, 0. That makes much more sense. There we go. -2, 0. And that our line here is gonna, it's curvy, so it's gonna reflect that same curve. It's gonna do the opposite of the other one. So like this one went down, so this one's gonna go up, and looks like it's gonna cross pretty close to the same point. There we go. That should be a 0. Okay, so see how the blue line and the purple line are reflecting over that y equals x line. So yeah, that looks good.